Buenas tardes, React Alicante. What an amazing conference. Here we are at the very end. Just one more talk. Maybe that makes you happy, maybe it makes you sad. I don't know. My name is ERIK RASMUSSEN, and today I want to talk to you a little bit about visually coding backend logic with state machines. Now, we learned a little bit this morning with David's talk about what state machines are, but I just want to go over that one more time. A state machine is something that defines an initial state, and then it defines some finite number of other states. That's why sometimes it's called finite state machines. And then it defines events that can transition you between these states. Sometimes it can do other things, like David showed about firing off side effects, but we'll get to that in a moment. Now, state machines on the front end have slowly become more popular as we're getting rid of all those use effects. Generally, on the front end, what you do is you instantiate your machine, and then as the user interacts with the UI, events are sent to the machine, which then may or may not transition into a new state. And if you're using a declarative UI framework, if any come to mind, then you can change the UI as those states change. And in general, machines are on for the lifetime of the component or page. Now, on the back end, things are a little bit different. Normally, on the front end, a state machine will have like a final state, where once you get to that state, the machine shuts down and it won't accept events anymore, and it's just done. But on the back end, if we're going to give data back to the user, we need what I'm calling pause states, where you transition to various states, and you have to mark some of them as being, when you get to this state, even though it's not a final state, you need to give the response back to the user. And not all states are pause states, because sometimes you might want to transition to a state where you are waiting for some fetch to come back from another service, and then maybe you go to another state, and then you need to talk to Stripe or whatever. And then finally you get to a state that you've marked as a pause state, and only then do you give the response back to the user. But we have a complicated problem here of where do we persist the machine? Because HTTP is fundamentally stateless, and now that we're moving away from servers to serverless and to putting everything on the cloud and the edge, we have to figure out some way to maintain our machine. We can't start from fresh every time. So we could serialize it into a database. That's an option. Some sort of a session store or like Redis or something. But for the purposes of my demo today, I'm going to use the humble cookie, because as I saw during snack time, everybody loves cookies. Now, we have this other problem in computer science, called the halting problem. And it states that there is no way to be certain that your computer program is ever going to finish. You can't know if you're in an infinite loop, because it's just a black box and you just don't know. So, as a result of this, so if you're thinking about state machines on the back end, you can never be sure that you're going to get to a pause state. So when you're implementing state machines on the back end, you absolutely must set some sort of a timeout. So if it takes too long to finish whatever it's doing, then you need to time out and come back to the user. Now, how do we do this? Well, my favorite state machine library is xstate, and by the Stately team, who are our sponsor. And they have provided this wait for API earlier this year. Now, normally the way that you use an xstate state machine is with this interpret function. So I've called my function async interpret. And it takes the machine definition and how long you want to wait. Just as a side note, I do a lot of stuff with timers at my job, and I highly recommend that if you have a number in JavaScript that represents a duration, that you put the unit there so you know if there's seconds or milliseconds. I see all of you nodding because you've all run into this. Okay, back to the content. So you also give it the initial state, and optionally some sort of initial event to run when you start it. So we create a service by using the regular interpret function on the machine definition, and then we sort of boot up that service at this initial state. And then if we happen to have an initial event to pass, then we pass it, and then we wait. It's going to be calculating all its things. Maybe it's fetching something, we don't know. And then we call wait for, which, as you might imagine, returns a promise, which we're going to await. We give it our service that we've already started and set running, and we give it how long that we're willing to wait. And then we give it this predicate. And this predicate is going to be called every time the state machine makes a transition to a new state. It's going to check with us. And if you're in a final state, state.done is going to be true. And at the moment, Xstate has no first-party way of marking pause states, but they do have this arbitrary tagging system where you can just tag your states with whatever. So for my example, I have tagged the states that I want to be pause states with a pause tag. So when this predicate returns true, my promise is going to resolve, and I can give my data back to the user. And if it returns false, then we're just going to keep waiting until the timeout passes. So using this, we can now safely run a state machine on our backend, serverless, wherever. So a little bit about the architecture of what I'm going to show you today. States are routes, specifically pause states. And if you take a moment to think about it, routers are inherently state machines because you go to a web page and you're on the root path, and you click the link, and that transitions you to another route, and you click another link, and that takes you to another route, and then you hit the back button, and that takes you back. You're transitioning between these states, right? And that reminds me, it's really fundamental that we do not break the back and forward buttons. The web users really expect that to work, and I'm sure you've all had a website where you submitted a form and then you hit back and it said, do you want to resubmit the form? And you're like, no, I just want to go back. So that's really fundamental. And we're going to do this by implementing a go-to event. So whatever state the browser thinks it's in from its route, we're going to tell the state machine that we can force the state machine to go to whatever state that the browser thinks it should be in. You'll see how that works in a moment. And like I said, we're going to serialize the state machine to a cookie. And we're going to use this async interpreter thing to run our machine. And because I'm building this on Remix, my current favorite platform for building React stuff, we're going to, and Remix is all about like going back to fundamentals and using the platform. So the way that we're going to send our events from the client to the server is using form data, submitting forms. That's the way that the web was built to, when you want to talk to the server, you submit a form or you click a link. And here we actually want to send data, so you have to submit a form. So how are we going to do this? Well, say we want to send a next event to move to the next state in our state machine. We're going to use Remix's form component. We're going to set the method to post, and we're going to use a regular old HTML submit button. Now, some people that are more new to web dev and might not remember or have learned that back in the old days, you used to be able to give a name to your submit button. That's how we knew which submit button on the page you clicked, if there are many. So we can just give this name and value to the submit button. And then when we deserialize the form data on the backend, we get this JSON object, which just so happens to be the exact format that XState wants for its events. But what if we need to pass like some extra payload in our event? This is just a single event. What if we need to send more information? Well, for that, we use an ancient technology called the hidden input. Back in the old days, you had a list of records that you wanted to edit, and you clicked edit. You showed the form of editing the thing, and then when you submitted the form, the backend had to know which record you're editing. So typically, you would put the primary key of that record into a hidden input, because you don't want the user to be editing that, but you want it to be in the payload that gets sent back. So we just give a name and a value pair. And that is when we deserialize our form data on the backend is just going to appear in our JSON. And same thing with the submit. We're just going to send our type, and that's going to be the type of our event that we're sending. Now, the way Remix works on the backend is there are two types of things called loaders and actions. A loader is what is run when you hit a route to fetch any data that is needed, and an action is what happens when you submit, you repost to a route. So in my application here, I have a route loader, and so this is when you hit the route, which is a thing that British people can't say. They say root. Anyway. And then there's a dynamic route for whatever state we're in. So if you've used Next.js or things like this, that $state is going to be just a dynamic route that we're going to get whatever that value was. And then we're going to have an action for when you submit on that dynamic route. So I'm going to briefly go over some code here. I'm going to put up a GitHub thing at the end where you can look into it with more time. But the root route loader is going to read if you have the cookie for our machine, and if you do, then you're already in some state, and we're going to get that state. That's state config.value is whatever state you're in, and forward you there. So if you made it halfway through the checkout process and then somehow go back to the root, it's going to take you to where you were in the checkout process. And if you're not, then we're going to boot up a fresh version of our machine, calling the swag store machine, and that's going to, we're going to give it that 3 seconds timeout, and that's going to do whatever initialization it needs to do until it gets to a pause state, which means this is going to resolve. And then we're going to redirect you to whatever state that machine thinks it's supposed to be in. And of course, we serialize the machine to the cookie. Now, that is going to take us to the dynamic route. And here we get the state. That $state is going to come to us as a variable in these params. We're going to read the cookie again. If for some reason we're on this thing and we don't have a cookie or a state, we're going to redirect back to the root, which is going to go through that thing and reinitialize our machine. And then we're going to convert that cookie value into a state that our swag store machine understands. And if we're already on the route that corresponds to the state that was in the machine in the cookie, then we're going to just give back that current state as JSON. And if we happen to be in a final state, then we're going to blow away the cookie. Otherwise, we're not. But if we're not in the state that matches the route, then we're going to have to interpret our machine, and we're going to send that go-to event that I talked about. So we're going to give it the machine, timeout, and the current state that the cookie version of the machine thinks it's in, and send it the go-to of what the route thinks it is. and that's going to immediately transition us there. And then we're going to send the machine state and the cookie back to the client. Okay, one more bit of code and then it gets interesting. So the action, remember this is what happens when we are giving an event. The action is doing the same sort of thing where we're reading the cookie, and if we don't have it, then we go back. And we deserialize our form data. This is how, again, this is like, because Remix is just using regular JavaScript APIs, this is like not anything special. This is just the way you do stuff in JavaScript. We're going to get our event, and then we're going to async interpret our machine with the timeout, and we're going to give it that initial event and the current state that we got from our cookie. And if our next state is not the same as the route that we think that we're in, then we're going to redirect to that route and save the machine as the cookie. Otherwise, we're already in the right route for that state, so we're just going to send back the state because not all events are going to change the state, the route that we're in, as you will see. Okay, and then we're going to send the cookie. So a little bit about XState terminology. There are things called guards, which are just predicates that determine whether or not you can make a transition given an event. And then there are actions that are side effects, as we learned about this morning, that can be many things. But a common action is to update some data in our context. And context is not React context. Context is like local storage inside of our machine. If you've used Redux, think of it like a Redux store. It's just this place where we can save information. And services are ways that we communicate with the outside world for fetching data or for talking to maybe another state machine somewhere or anything where we need, it's not a fire and forget action, it's a thing where we need to go and ask something and wait for the response. Okay. Here comes the fun part. We are going to attempt some live visual coding. Okay, that was a fun intermission. So this is my state machine. This is the visual editor from Stately that David demoed earlier. A lot of boxes and arrows here. Looks potentially complicated, but let me walk you through exactly what's happening. So first I'm going to use the simulate functionality of this editor. And we're going to start off, I'm building a little checkout process. We're going to start off in the cart state. This little widget here says that this is the initial state. And each of these blue things are events that I can simulate passing. So if I click on this, then it's going to run this decrement product action, which is going to decrement the count for a particular product in our cart. Increment product does the same thing. And again, we're staying in the same state. We're just modifying our context with those actions. And here I have a checkout event, and this is a guard. So only if I have chosen some items in my cart am I going to be able to make this transition. So when I do that and I have items, now I'm over here in the shipping state. And here I can go back to cart if I want to, and check out again. I can hit next, which is going to save my shipping information. And now I'm in billing. And maybe I hit back twice, or I hit, I want to go back twice. So this go to event is that it comes down from the top here means that it's global. No matter what state you're in, this event can fire. So maybe I go all the way back to cart, and then I have to go back over here. Now I'm in billing, and go back to shipping. You get the idea. And now when I place order, I'm going to save my billing information that I entered in that form into context. And now I'm in this placing order state. And this placing order state is not a pause state. It is invoking this place order thing that's going to save my order information in the database. And when it's done, it's going to come back with order placed. And now I'm in order success, which is a final state. That's what that little icon means. And so that's sort of the flow of what our cart is going to look like. So what does that look like on our website? This is the extent of my design skills. This is our cart. And when I hit plus, hold on, let me refresh this. When I hit plus, we're incrementing these values. Now, what's happening when I press plus here is I'm submitting that form, but Remix is noticing that I'm submitting that form, and it's calling prevent default and sending a fetch to the server, and the server is going through this increment and decrement thing here, updating my context and staying in the same cart, which is a pause state, and it's giving me back my data. So as I'm doing this, I'm sending these fetch events to Remix, and it's passing it through my state machine. When I hit proceed to checkout, I now go to a different state. I'm in a different route. The route changed. The back button works. I can go back. I can go forward. I can hit this back. I can proceed to checkout again. And I can type in my name here. But we don't have any states here. So the contrived example of this demo is that I need to load states depending on which items I have selected in my cart. I'm going to load a different potential like US states that we can ship to. So how do we do that? So this needs to happen when we are in the cart and we click checkout before we get to shipping. So I need to transition into a state that is going to load my potential shipping states. So I'm going to create a new state here called loading shipping states. And when I'm in this state, I'm going to invoke load shipping states. This is a function I pre-wrote. And when I am done with that, I'm going to go over here to shipping. And I call this event, name it here, shipping states loaded. And what I'm not quite done because I have to save these values to the context so that they're in my payload when I come back. So this is set shipping states, I believe. Now, the way that I make this work is, watch this. From checkout, I need to go here instead. So I'm going to grab this guy. Watch how hard this is. Okay, so now when you hit checkout, we're going to go to this other state that's going to go fetch these values. And when the values have been fetched, we're going to set them into context, and we're going to go back into shipping. Now, as I've been fiddling around with my arrows here, this XState editor has been modifying this JSON over here. See? Now our target is going to load shipping states. So it's been doing that. And when I save, Remix will already load that back in. And so now, this didn't work the last time I gave this talk, but now when I proceed to checkout, it should take a second, and then we should have shipping states. So I pressed it, took a second, and it didn't work this time either. Proceed to checkout. Took a second. We don't have shipping. Oh. I bet I didn't call it. Oops. I called it save shipping states. Look, there's this JavaScript is unhappy here. TypeScript is unhappy here because I called this the wrong thing. I don't feel so bad because the same thing happened to David this morning. So. Now TypeScript is happy. I said now it's all loaded, and now when I press proceed to checkout, it takes a moment and it actually saves my states, and I have my states here. So and so now I'm from North Carolina, I can save, I'll pay for it myself, and I place order, and it takes a moment to go and send the thing, and now I've placed my order. Now, just one more little thing. Remember I said when I'm submitting these little forms here, Remix is calling prevent default and sending a fetch up. If we are very brave and disable JavaScript, and then I refresh this page, and the proof here is that these JavaScript files have been blocked by the app, there's no JavaScript running on this page. So now, when I press the plus button, here, let me actually refresh this. Now when I press the plus button, it's actually doing the regular HTML default thing of submitting. It's reloading the whole page. This is a simple page, so you can't really tell, but it's actually going and fetching a whole new version of the page. I think we might be able to see that in the network tab. So yeah, it's gone and fetched this whole other version of cart again. So I have no JavaScript on this page, and yet I can tap these buttons and it's incrementing my stuff. I proceed to checkout. It took a moment, and I still have states. Send this to who lives in California, Michael. And I hit next, and I can change this, blah, blah, blah. And now when I hit place order, again, it still works entirely with no JavaScript, and it all just worked. And that confetti is actually CSS. Okay, so to briefly recap what we have shown here is we're using these pause states as routes, and the machine can go and do different things, and then once it gets to a pause state, then we send the information back to the user. So the browser is allowed to spin briefly, and we're using these async states to go and fetch data and submit data and to save data. And we've got this timeout to ensure that we don't wait for too long before we give some feedback back to the user. We were able to maintain the back and forward buttons using this goto event, this global goto event that could take us to whatever state we needed to go to. And we're passing events as form data, just like HTML wants us to. And we have this beautiful design tool for the backend logic that lets us just drag and drop our logic. And if we wanted to add another step, you can imagine how easy that would be to add a different step, like an order confirmation page or something. And because we were using the platform with events passed as form data, it worked with no JavaScript required whatsoever. Now, before I go, I'd like to talk to you a little bit about coding and how, as developers, we all work. I'm sure you've all experienced this thing where you're just so deep into your code and you're just so concentrated that it's like the rest of the world just like falls away and you're there so focused. This is what psychologists call a state of flow. Athletes and musicians and dancers all report this same feeling of losing themselves and losing time, and when they're really at their peak performance, which it's a generally enjoyable state to be in. And I'd like to encourage you all to check out an app that I've been working on for the past year. It helps developers just like us get into flow state and stay there, not get distracted. It's called Centered. Center.app is where you go. It's a desktop app that you run on your Mac or Windows computer to help you be more productive. And I was able to beg and plead with the corporate overlords, and I got us an offer code for a free trial of a free month of our Pro subscription. Hopefully you can remember that, take a photo or whatever. Encourage you to check it out. Gracias, Alicante.